Hello everyone, and welcome to our webinar Introduction to MicroK8s. I am Alex Chalkias, Product Manager at Canonical, the company behind Ubuntu. I am responsible for our Kubernetes and container product portfolio. Today, we'll go through an overview of MicroK8s, one of our two K8s distros, alongside John Kubernetes. MicroK8s was initially released in late 2018, and we have seen significant adoption from developers and enterprises alike ever since. The purpose of this webinar is to further raise awareness on what MicroK8s is and what its benefits are. We will also cover some of its main use cases, including DevOps and AI/ML workflows. At the end of the webinar, I'll do a short demo, and we will also have a Q&A session with my colleague and lead developer of MicroK8s, Konstantinos Tsakalosos. Let's start by defining MicroK8s. It is a lightweight, pure upstream Kubernetes aiming to reduce the barriers to entry for K8s and cloud-native application development. It comes in a single package that install a single node or standalone K8s cluster in under 60 seconds. You can also use it to create a multi-node cluster with just a few commands. MicroK8s has all the Kubernetes core components, and it is also opinionated. What this means is that a lot of the add-ons that you would typically look for in Kubernetes, such as DNS and the dashboard, are a single command away. MicroK8s is available for most popular Linux distribution and also for Windows and Mac Workstation through a native installer for both operating systems. On Windows, you also have the option to get it on WSL. It uses the snap packaging mechanism, which is really convenient as this brings automatic updates. This means that as soon as the new stable Kubernetes version is available upstream, your MicroK8s cluster will be automatically updated. You will similarly get all available security patches for your K8s. So who is MicroK8s for? MicroK8s can be equally a developer's friend as well as the go-to Kubernetes for enterprises. You just need a Kubernetes, right? MicroK8s is the easiest way to get one. You can use it on your local workstation for development and testing. Its low resource footprint and support for both ARM and Intel architectures make MicroK8s ideal for edge, IoT, and appliances. We see a lot of people using MicroK8s on the Raspberry Pis, and we also have a few great tutorials for that, which you can access through the Attachments tab beneath this video. The thing that I personally love most about MicroK8s is the zero ops experience. I'm not ashamed to share that before I discovered MicroK8s, I had very little hands-on experience with Kubernetes. Now, with MicroK8s, I can have my Kubernetes cluster up and running with a single command, get security updates without lifting a finger, and run my add-ons without having to worry about configuration. Remember, if you are not like me and want to configure it, you can. In the end, it's just a Kubernetes. The latest improvement MicroK8s brings is the HA clustering. You can get a fully resilient K8s cluster by joining 3 or more nodes to your cluster and have MicroK8s automatically distribute the control plane across the nodes. MicroK8s gets full enterprise support from Canonical and 10-year commitment for critical deployments. We are actively working with all major clouds to simplify multi-cloud and hybrid cloud deployments and ensure our users get a carefree, production-grade Kubernetes. Here, you can see the complete set of features and add-ons that are currently supported by MicroK8s. Use Juju, Jazz, or Helm to automate operations. Use DNS, Ingress, Flannel, and Cilium for your project's networking. Use GPU acceleration for your deep learning projects, and if you're an AI/ML geek, combine it with Kubeflow as your home edition high-performance computer. Use Istio or Linkerd for service mesh and MetalLB for load balancing. Use Knative to write serverless applications. And if you need logging and monitoring for your projects, we have a full toolbox that includes Prometheus, Grafana, Elastic, FluentD, Kibana, and Jaeger. Now that we've seen what MicroK8s is, let's talk a bit about how it can be used by taking a look at some of the most common use cases. The first one would be DevOps and setting up of CI/CD pipelines. Doesn't matter if you need Kubernetes to run on your test on a local or a production CI/CD pipeline. MicroK8s is the easiest way to get Kubernetes. Start by building your containerized apps on local using MicroK8s with, for example, GitLab. Then move your apps to your test environment that is also built on another K8s. and finally deploy your containers in production. What I just described is a multi-step process that requires a lot of configuration to be set up. With MicroK8s, that's no longer the case. After you finish with your tests, you can, with a single command, either reset your K8s environment or even stop the MicroK8 service to save resources. Another significant use case is building AI/ML pipelines on top of MicroK8s. When we look at a machine learning teams, data scientists often end up working in silos, meaning they each create different parts of the workflow, resulting in hard to share and hard to maintain notebooks and scripts. This is because some of the tools they use do not enable multi-user environments. Further, setting up the right infrastructure for cost-effective AI/ML is cumbersome, and often data scientists lack the necessary know-how to do the setup themselves. MicroK8s addresses both silos and infrastructure challenges, thanks to Kubeflow and GPU acceleration. Kubeflow bundles one of the latest and greatest collections of AI/ML tools that enable sharing of AI workflows between teams. Running Kubeflow on top of MicroK8s is as easy as microk8s.enable Kubeflow. GPU acceleration allows for model training compute requirements to be taken care of. Again, enabling GPU acceleration with MicroK8s is just a command away. You can deploy MicroK8s clusters on top of any infrastructure, such as a laptop, a cloud VM, or an on-prem server. This abstracts the complexity of setting up the substrate and lets data scientists focus on their models instead. Let's get a bit more hands-on, shall we? In this demo, I will show you how easy MicroK8s is and how straightforward it is to deploy your applications on top of a MicroK8s cluster. The setup that I will be using consists of three different LXD containers that run on my Ubuntu 2004 LTS workstation, which is a 3-year-old Dell Latitude with just 16 gigs of RAM. I'm using LXD as a quick way to spin up machines. Each LXD container runs a single MicroK8s instance. I will be logging into every machine and interact with MicroK8s, cluster the three instances together, and deploy a few demo containers on top. So let's get started with our demo. As said before, I'm using three LXD containers on top of which I run MicroK8s instances. So you can see here, I can do my LXD list. And here are my three LXD containers named MicroK8, MicroK8s2, and MicroK8s3. What I can do now is I can do a LXD shell MicroK8s to actually SSH to my Lexi container. So I can do, here I have already installed MicroK8s. So I've already run sudo snap install MicroK8s -- classic. And you can see that if I do a MicroK8 status, MicroK8s is running. And I have the same thing here on my second and my third Lexi container. So what we will do is now focus on the first instance of MicroK8s, and I will show you how easy it is to enable a few add-ons. So MicroK8s enable, let's say DNS and dashboard. So I can do another check of my add-ons. To see that the dashboard and DNS have been enabled. So now I want to access my dashboard. So I will do MicroK8s kubectl get all all namespaces. So as you can see here, I have my Kubernetes dashboard service running. This is the cluster IP. Remember that since I'm using LXD containers, I need to do a port forwarding from MicroK8s to LXD, so I can actually see the dashboard from my host browser. So I will go now to my browser. This is the IP that I'm using, and I'm forwarding to port 443. So this is giving me the dashboard. I have stored the token previously on a file, so now I can copy it, and I can go here, paste it, and there you have it. So now this is the Kubernetes dashboard, and I can see my MicroK8s node that is running. So what I will do now is I want to join the other two MicroK8s instances to the first instance. So this is quite easy to do as well. So what I need to type is MicroK8s add node, and then I need to take the output of that command and copy it on the other node. And then I need to run another add node command and take that output and copy it to the other node. So this will take a minute to finish. And then so now we see we have root MicroK8s2 that has joined the cluster, and there we have it, MicroK8s3 has also joined the cluster. So in order to see everything that we did, we can use MicroK8s kubectl get no. As you can see, we have 3 MicroK8s instances that are clustered together. So now if I go back to my dashboard, we'll see that we have 3 nodes of MicroK8s. So this is how easy it is to actually create a multi-node Kubernetes cluster with MicroK8s. What I also want to show you now is how to deploy an application on top of MicroK8s. So I need to write MicroK8s kubectl create deployment. My deployment is called MicroBot, and I need to give it the path to the image. So I have created my MicroBot. So MicroK8s kubectl gets all namespaces will give me a view on my MicroBot deployment. So if I want to scale up my MicroBot, say I want to create 3 replicas of it, I need to say MicroK8s kubectl scale deployment MicroBot replicas. Let's say we want 3 replicas. So we can see that the MicroBot deployment has scaled. And if I do all namespaces, I will see 3 pods of MicroBots. So now, in order to see what I have deployed actually, I need to say MicroK8s kubectl expose deployment microbots of the type node port. I want to expose it on port 80, and its name is microbot service. So again, I have the microbot service exposed. So this is its IP. Again, I will be using some port forwarding from MicroK8s to LexD in order to access the microbot service from my host. And if I go check it on my browser, this is my microbot. So as you can see, this is a 3D rendered image, and I can see the name of the pod that is hosting the service. So what's interesting here is how replicas function. So you see, this is the name of the pod. So if I go back here, I can do MicroK8s kubectl delete. I need to wait for the pod to be deleted, and then you'll see something interesting happening. So now my pod has been deleted, and if I go back to check all namespaces, remember, these were the names of my pods. Now I have a different name instead of the previous one that was deleted. And this is because I've said that I want this deployment to run always on 3 replicas. So now, if I go to my browser, I expect the pod name that was under the microbot to be changed to either one of these 3 new pod names. And yay, I have my new pod name here. So this is the end of our demo. Hopefully this was useful to you and you've learned how easy it is to deploy MicroK8s to enable the Kubernetes add-ons with the simple command, and how to cluster MicroK8s instances together and deploy applications on top of it. This brings us to the end of our webinar. Here are some key takeaways and resources. Remember that MicroK8s is a production-ready, pure upstream K8s on Rails that comes with baked-in add-ons. MicroK8s is available for all major Linux distributions, Windows, and Mac OS. You can use it for local development and testing, clustering, DevOps, AI/ML, IoT, Edge, and appliances. You can find more about MicroK8s on microk8s.io, and you can hit us up on Slack or GitHub. There are also some cool videos being uploaded on our YouTube channel. Of course, feel free to contact me on my personal channels to discuss any cool ideas you might have using Kubernetes and containers. Back to you, Alex, for the Q&A. Thank you.